Hey guys, so welcome to day 7 of, you made it through a week, of distance learning. Today we're going to be finishing up minerals. This is going to be the last thing that's on your tri-quarterly exam. Tri-quarterly exam is coming at the end of the week on Thursday, remember that. Here's the schedule for the week.
Okay guys, just notice that Friday through Monday there will be no distance learning, but if there is anything that you need us to double check, a lab that you may have posted late that we didn't grade, or you have questions on the homework, that would be the time to actually do it. Would be between Friday and Monday. We're both hoping to get all of our grades done by Friday so that we won't have to worry about anything. That includes, guys, your final grades with your Q3 project grades done.
Yeah, those have not been touched. Those have not been graded. We did put in who handed them in. If you had issues submitting them and you submitted them to like Google Classroom and you couldn't get on, turn it in. I would say try again to put it on, turn it in. I will not do any penalties if it's already handed in on Google Classroom and now you put it in to turn it in, you're perfectly fine. We understand last week a lot of people were using the internet for the first time for distance learning. It was Wi-Fi issues and stuff like that. So we'll give you a little bit of a wiggle room with that. But it had to be handed in at some point, the beginning of last week, on Google Classroom or all on Turnitin or something like that.
Or emailed, whatever
or
you did.
Or emailed or something like that. As long as we already have a copy, and it might be not in the correct place, but now if you can put it in the correct place, the platform seems to have stabilized a little bit better, so you should be able to do that. All right, so I'm going to do the regular lesson today, same as always, voiceover, pretty pictures. And Miss G is going to go over the homework from last night, and she's going to do a supplemental video. They'll all be on the YouTube channel. They'll all be on your Google Classroom. Make sure you do it. Any questions, put comments on Google Classroom. It's the easiest way for us to get you guys. I have synced it to my phone, so has Miss G. So anytime a comment pops up, that's how we get back to you. So that's probably the best way to get in contact with us. The email's okay, but the comments right now are probably the best way.
Don't forget, Wednesday we're having office hours on Google Meets, I think it is. If you don't know how to use that, you can email me at this point. I believe most of you have done a Google Meet from the calendar that I just saw. All your teachers are doing them. So you have to have your iPads hooked up, and I believe you have to download handouts or something crazy. We'll send you guys the directions once we have them. If not, keep checking the SFP calendar because it should be linked to it at that point. So we're going to be having office hours Wednesday at, we said
1 to
2:30. Okay, so if you have any questions, your best bet, guys, is to email me the question ahead of time, and then we can talk about it in the Google Meet session, just because it's a mess. Just letting you guys know, we're going to try and keep it as organized as possible, but we're learning it just the same that you guys are.
All right, guys. We'll see you later. Peace. All right, guys. So today we're going to talk about mineral groups. We're going to talk about the ways we classify minerals. Now, minerals are usually broken into what we call rock forming, which means they become a rock, or economic minerals, which are the ones that we use. Now, when we talk about a mineral, remember, it has to hit all those criteria. It has to have a chemical formula, it has to have a crystal shape, and all that stuff. So since you have a chemical formula, that means you have to be made up of certain elements. There are actually only about 8 elements that make up almost all of the minerals, and therefore rocks, in our crust, the outer layer of the earth. That's oxygen and silicon, aluminum, sodium, calcium, magnesium, potassium, and iron. You can actually find those on page 1 of your reference table. If you look down at the bottom, it says the chemical composition of the different spheres. Where you see the first one says crust. Now it's important that you pay attention to something on this crust. On this chart, I should say. There's 2 columns. One says the percent by mass. The other one says percent by volume. When you're asked a Regents question, it's really, really important that you pay attention. Are they asking you the percentage by mass, or are they asking you the percentage by volume? They are different things. All right, so when we look at this chart, you can see that it's all listed there. Okay, now it's really, really important, guys. I said this before, but if you look at it, you'll notice that 2 of the elements make up a huge percentage of the elements in our crust, those being oxygen and silicon. Okay, oxygen and silicon make up over 70% of all the atoms in all the minerals on Earth. Okay, combined, these 2 make something that we call silica. Okay, silica is something that we're going to talk about a lot over the next couple of days and couple of weeks, because it's an incredibly important part of what makes up rocks and or minerals. Alright guys, so the first mineral group that we have to know are what are called silicates. Silicates are minerals which contain oxygen and silicon bonded together. That's that silica stuff. And they're bonded together into a shape called a tetrahedron. I'll show you what one looks like in a second. Now, a lot of times silicates are going to tend to have other minerals inside of it. They're going to tend to have some of the other ones, the potassiums or the magnesiums, which makes the variety of stuff that you can see. So you can see the silicon tetrahedron right here. In a silicon tetrahedron, you have the silicon in the center, and then around it, in like a pyramid shape, you have 4 oxygen molecules. Okay, and so this is a silicon tetrahedron, or silica tetrahedron. Okay, now when we talk about silicates, okay, silicates are all going to form usually as molten rock, so lava or magma, cools down and then solidifies, crystallizes. Okay, we talked about this when we did phase changes. When that magma or lava crystallizes, it forms 2 main groups of silicates. We call these the light silicates and the dark silicates, obviously because of the color. Light silicate is the one that you see first on the board on the left-hand side, and the dark silicates are the ones that you see on the right-hand side. Now, when we talk about light silicates, they obviously are lighter in color. Okay, they tend to have a relatively low density, about 2.7, and they have lots of aluminum, potassium, calcium, and sodium. What they are missing is stuff like iron, Fe, and magnesium. Okay, and we can see them as lots of different types of minerals that were important to us, stuff like feldspar and quartz and things like that. Okay, feldspars are really important. We're going to talk about them a lot. Okay, they're the most common mineral group. We see them all across the crust. They form all over the place. Okay, they form under lots of different temperatures and ranges. Some of them are light colored and they look like they have scratches on it, like the mineral you see on the board now. Some of them are a little bit more pinkish to orange in color and they lack the scratches that you see about this. Now we'll talk about this when we actually get a chance to actually do the hands-on version of this. Okay, quartz, we talked about this a lot. Quartz is just made of silica by itself, pure silica. Okay, when it does this, it usually has that clearish color. Okay, but sometimes you do get like a another element that sneaks in and it can change this. Now, if you're just quartz and you're just silicon and oxygen, it's just covalent bonds, which means you have a very strong, a very durable, and a very hard mineral, which is why it has a hardness of 7. Okay, and so you see the picture on the board now has 4 different mineral samples. They all look different colors, but they're all quartz. But the ones that are slightly colored have some sort of impurity which changes their color. The next group we're going to talk about are the micas. The micas are really easy to identify. They tend to be shiny and they tend to make very flat crystals and things like that. They peel apart. They almost look like they're made out of plastic wrap. Okay, you can easily peel them apart into thin sections that are translucent, which means you can see through them. And mica is usually easy to identify in a rock because it gives the rock a sparkle. It makes it look like it has glitter. If you look at the samples that we see above us right now, you can actually see that in the rock. You see how it looks like it's covered in little bits of glitter. Okay, and so that's what happens when we talk about micas. Okay, when we talk about the dark silicates are going to be a little bit different. Dark silicates tend to have a lot of iron and magnesium, and they're missing stuff like potassium and calcium. Okay, they tend to be much darker in color. They tend to be much heavier, much denser minerals, like you see in this picture here. The rocks in this picture are forming out of this volcanic vent. That guy is, you know, a brave man walking that close to a vent, but you see how they're very dark. They tend to have lots of iron in it, and they tend to have lots of what we call dark silicates. Okay, now examples of dark silicates would be things like garnet. Garnet is usually a single tetrahedron bonded to other minerals by metallic ions. Okay, garnet is the birthstone of January. It's very bright, very impactful reddish stone. You can see it in the picture here. Okay, we usually find it in metamorphic rocks. Okay, another example of a dark silicate would be something like pyroxene. Pyroxene usually forms right around volcanic vents. It's very dark in color, very large crystals, and you can see it in the image presented to you before here. Now, there are some minerals out there that are not silicates. They don't have silicon and oxygen in them. We call those non-silicates, and there are a ton of them. We've talked about one of them. Example of this would be something that we call calcite. We saw it last time. It was the one that when we dropped the acid on it made the little bubbles. Okay, and so calcite would be an example of a non-silicate. There's lots of those. We'll talk about those when we actually get to do the lab, if we get to do the lab. The last group we want to talk about are what we call native elements. Native elements mean that that mineral is made up of just one single element and one group of atoms, and they're all bonded to each other. So it's all made up of things like copper, like you see the picture in front of you. This is all copper. This is pure copper, all linked to itself. Okay? Or Mrs. G's favorite, pure elemental native sulfur, which is the one that you see right here in front of you. These both would be example of native elements. Native elements are single elements, all bonded to each other, not connected to anything else. All right, guys, so I hope you enjoyed that, and I will see you guys tomorrow. We will talk to you guys tomorrow. Catch you later.